Welcome everyone to another video in my hands-on track series with HackTheBox, and this is again the binary exploitation track, and today we're looking at the optimistic challenge. How do you get there? You sign into HackTheBox, you go to the tracks, binary exploitation, optimistic, download the file, and I already did that, unzip it with a password, and then you're gonna analyze it, you're gonna write your exploit, and if you're lucky, you'll end up with something like this, and you get an interactive shell. That's pretty cool. And on the remote machine, you can, of course, then cat the flag. I'm not sure if I have a flag txt in there, honestly. So how do we get there? We run the binary. That's usually one of the first things to see, okay, what's there, what's happening, and get a little bit familiar with it. And we also run checksec that basically tells us a little bit about the compiler flags of this binary. And one thing that's very interesting here is, so there's the non-executable stack flag disabled, which usually prevents user input from being containing instructions that are run, and it's not on purpose of the programmer usually. Then here we have some inputs. Of course, those will be useful, and we will walk through these inputs as we walk through the code. How do we get through the code? Well, Ghidra is the tool of choice. Load the binary in there, double click it, it will open the code tool, the code browser. Just hit yes and analyze. That's good enough for us for now. It loads the binary assembly in the left hand side and the decompiler views on the right hand side, which is a really cool view, especially starting out with assembly and you don't know everything that's happening here. Like some people look at this here and this is what happens in their head. In my head, that's not really happening until now. So I'm very happy that this decompiled view is there and gives me kind of a better idea of what's going on. So you can copy this over into an editor. And what you can also do is, as you may see here, I've renamed kind of a lot of these variables. This can be done in Ghidra if you click on a variable and you just hit L on your keyboard, and then you can rename that to whatever you want. So as I didn't want you to look at me renaming all these variables, I did that in advance. And the program here calls initialize and puts out some phrases and questions. Then it asks for yes or no, so it gets a single character and then casts that character into another variable. So obviously this single char variable is an integer, which is usually not a problem, but you will see that actually this is part of the trick of this challenge, that a lot of things are getting casted into other things. And by saying things, I mean types, structures. If it's not a yes, we will basically exit. And of course we want to enroll, so we will say yes in our exploit, and then we will continue here, and it prints out the stack address for us. Important that we go back now to the code browser and look. The stack pointer here actually contains the base pointer. So, which means if the base pointer is our stack pointer, and this is all in our stack, to get to the beginning of our input, which you can better see here now, the name, we have to go back from that address. We have to go back 96 bytes. So keep that in mind. It's very important for our script later. So if you use this address as is, you will basically not get anything because you're already past our input. So it says, please provide some more details. This is only getting 8 bytes here in the buffer, assigns it to, I just said it's a string email. I mean, here it's undefined, same as age, but well, it's good enough for us here because the vulnerability is not in email and it's not in age. But definitely there's something interesting by asking us the length of our name, and it's checking the length of our name as an integer, cast that into an integer against this hex 40. And this is what I totally did not understand when I did this live, not prepared, didn't do any homework, didn't know about integer over or like overflow, underflow, wraparounds. Wraparound is what I wanted to say initially, actually. So there are hex calculators that you can use. You can just Google, and if you put 40 here, you can see that this is a 64. Another way of doing this would be just go back here, scroll to the OX40. If you would hover over this, it shows 64 as decimal. If you right click it, and yeah, it also shows decimal 64. Or you can even right click it here and convert it so it will literally show 64 here. Okay, well, it basically checks if it's greater than 64 and then says, oh, sorry, we will exit again. So it shouldn't be greater than 64. But what's very interesting here is that if we put in our name, it's actually as an unsigned long. So, excuse me. I thought, well, to understand this whole integer wraparound thing and what's different between unsigned integers, signed integers, and so on and so forth, I did a little bit of a C program as homework. And I just used an unsigned integer, signed integer, and an unsigned long, similar to the program that it compares stuff to. And I thought, okay, let's just compile this and run it. So we will exit this and clear this. And basically what we'll do is we will compile this script. And then, since I did not give a name, it's just called a out. And I can put in a 1. And oh, guess what? A 1 is always a 1. Well, interesting. So next thing you might check is a 0. Well, a 0 is always a 0. But now it gets interesting. We put in a -1 here. And what's happening here is an unsigned integer or an unsigned long can obviously not have any negative values. So what happens is that this whole range of an unsigned integer basically goes from 0 and says, hey, wait a second, like if you subtract 1, let's just go to the super maximum and subtract 1 there. So that is the integer wraparound, and this happens with this unsigned integers and unsigned longs, but does not happen with a signed integer. So this will be a -1, which means going back to our decompiled main function to pass this check, and remember this has been 64, we can just say, well, if this would be the integer of -1 would definitely be a -1, but once we are here, it will not be a -1, it will basically be the wraparound, and it will have this value. So it's very huge. And yeah, that's how to bypass this check. And I'm now very happy that I kind of could understand it a little bit better than not understanding it at all. So what happens next is we will loop here, and it will basically check our buffer, what we put in as an integer, but not the last 8, because it's less than equal, not the last 8, which will be our address that we jump to. And it will say, thank you, we'll be in touch soon if everything is fine. If it's not fine, it will basically say that's an invalid name, because it will break out of this loop by breaking here. And this checks if every single character is actually an alpha character. And not just that, it also checks if it's greater than 9 or less than, and 30. You can again go back here and convert that. 48. I would think it kind of has something to do with the ASCII table. But honestly, if you just Google for an alpha character-based assembly code, I think that's kind of enough. And I don't want to like blow up the video with going into some unnecessary details here, because we're already past 10 minutes. So let's get to our exploit. This is what I prepared. This is kind of a template that loads the optimistic binary as a target. It gets the context if it's 64-bit, 32-bit, Linux, Windows, whatsoever. It sets the debug level. Usually I don't like debug as a debug level or log level because it's just giving me so much output. I usually use print statements. So I prefer to have this at info. And then we can run this remotely by passing server and port as an argument, or we can, if not, run this locally, which is the first thing you would want to do. Then if you start the process and say send line after this byte string, so we would send a yes because we want to enroll, we will receive a gift, and don't do any crazy conversions, parsing whatsoever. Like, it's as simple as this to parse the output of our gift here. So just parse it as a base 16 integer. That's what you need to do. Email age doesn't matter. The length of the name now does matter. And what we learned when we ran this, we put a -1 here, just so we bypass the check and everything is awesome. So now the exploit goes here. That's what I indicated. And this is what I wanted to do together with you. So I said the stack address has to be corrected. And this is exactly what we will do. Stack address equals stack address minus 96. Because if it's at the very bottom, past all our content on the stack, and we saw that our array is kind of reserved with 96 bytes. Let's just go back 96 bytes so we are at the beginning of our input. Cool. So we've done that. Now the offset. And that's the offset that you use in the usual buffer overflow, because the base pointer address of the stack is followed by the return address. And the return address is what we would want to override. So since we know that 96 is our array, we would have to add 8 bytes to this. There is another way, I think, of doing that. If we go to the main function and we go here, here you can see for local 68 is minus hex 68. If we put that in here, you will also get the 104. So just take the 104 and put it as an, 104 and put it as an offset. Why can I not zoom in here a little bit more? Is that not done? Where's zoom? Appearance. I can enter Zen mode. No, I don't know what that is, but I wanted to zoom. Well, okay, we'll leave it just like this. And then we will basically say, before we can get to our interactive part, which is basically the last thing, we would say the padding we would need, so to fill up the space we don't use for our shellcode, would be, of course, an alpha character. So don't put a knob slat or something here because it will not work. I did that before and it didn't work. And now it's obvious why it doesn't work, right? So offset minus the length of our shellcode. The good thing is we don't have a shellcode yet. So let's see like what we can put here. So we can needs to be 64-bit alpha only. And honestly, I forgot what I used to Google this. Shellcode 64-bit alpha characters. Okay, so there is one here. NetSec. You can scroll through this a little bit. There's a Shellstorm one, and then there is one from ExploitDB. And usually ExploitDB maintains a very good source of this bits and pieces. And this is the one that turned out to be working for me. So I copied this over. I paste it here. And that will basically be our shellcode. So that's cool. It's I think 87 characters, what it showed on the website. And then we will basically wrap this up and say our payload will be our shellcode plus the padding plus, and then we will pack this stack address. And it will, you can see in this IDE, which is very nice, there's the word size. The word size is 64. The endianness is little. And then signed, we say no. You can also say false. And yeah, that is our payload. And now the only thing we need to do is we have to say p send line after. If it asks us for a name, and then we will send our payload. So let's save this as exploit.py, and let's see if that's actually working. We up this terminal, and we will, oh, we have to put in Python 3 exploit py, and hooray. Oh, I want to put a name there. It works. We have a shell, and we finally completed this challenge. It was not 10 minutes, it's 17 and a bit. Thanks for watching. Please subscribe if you like this video. Leave a comment, follow me on Twitter, Instagram, wherever you want. I'm happy if you reach out. I also have a Discord. Thanks so much, and see you next time. Bye-bye.